Okay, so we are looking at titration 4. It was a weak acid, strong base titration. The only difference, though, was that we had to dilute the vinegar, and they are going to ask you the reason why we dilute the vinegar. And you just need to realize that if we didn't dilute the vinegar, we would need huge volumes of NaOH. So you are doing this in the extra pages in your exam booklet for yourself. You are going to have to do your data table. So again, the terminology I'm using is attic and basement, such that we can still understand what we're doing once we get into the redox titrations in Form 6. So we have VMN. You will have had your own titer volume. This is the one that I am going to be using. We know in our basement we always have the perfect number, and in the attic it's always going to be the weird number, so not the whole number. So 25.0, our concentration was 0.1293 big M. You will have been taking that from an earlier titration. Our ratio, looking at the equation, is 1:1. So again, we infer that 1 is here and 1 is here. We just don't say that, but that's where those ones are coming from. And this is going to be my question mark. If you're looking at this in terms of a question, there will be something along the lines that says, what was the concentration of ethanoic acid? And that's going to help you to generate the question. Now, this vinegar dilution question is the only question where you have extra information that you may have to need. But any number that they're giving you, you need to make sure you're writing it down. So the extra information that we had was that we started with 25 centimeters cubed. We diluted it to 250 centimeters cubed. So you need to work out what your dilution factor is. And I personally would do it now. So it's 250 over 25, which gives me a dilution factor of 10. Every number that is on this screen, by the time we are done, you will have had to have used. Okay, the method that I am using is this W that I kind of invented on a very weird day to see could we figure out a process to go with this. So we divide our W in two, and you have to realize that this is the way in. So every number on this, in that particular column on the basement side, is going to be on this side of the W. And then when we flip over to use our ratio, we're going to go to the attic side. When we are done, we are going to have that question mark. So the 0.1293 is our way in. I always ask you to please expand this. What does it mean? So it's 0.1293 moles, and that is in 1,000 centimeters cubed. You now know at the bottom of our W that that is moles per centimeter cubed. So to go from 1,000 to 1, you know that you are going to be dividing 0.293 by 1,000. When you do that, whatever version your calculator gives you, you please use it. I always just default to scientific notation because it's less numbers to work with. So now down here I found the moles of my basement, my NaOH in 1 centimeter cubed. We know up here that these 2 points on the flat line have to do with our end point, with the titer volumes at the end point. So we also know that when we're going up on this funky W, that it's going to be a multiplication. So I'm trying to find the moles at my end point, and for us that was moles in 25 centimeters cubed. So I'm going to be multiplying this bottom answer down here by 25, and when I do that in 4 significant figures, I'm just going to change the color of my pen so you can see it, 3.098 by 10 to the minus 3 moles in 25 centimeters cubed. The flat line represents, as we've said, the endpoint information, and we use the ratio here, and our ratio is 1:1. Okay, so I've now used the 0.1293, I've used the 25, and I've used the 1, and now I'm flipping over to the other side. So this must be 3.098 moles, and it's in its endpoint, which is now 23.5 centimeters cubed of our acid. Okay, I need to go down, and at the bottom of all of these, the unit we're interested in is moles per centimetre cubed. So when we go down, it's a division. So the division, I didn't put in by 10 to the minus 3. So the division that we're doing is 3.098 by 10 to the minus 3. And I'm dividing that by 23.5 to find out what's moles in 1 centimetre cubed. So when I do that, I'm getting 1.318 by 10 to the minus 4 moles in a centimetre cubed. Our last step going up is to get us to that big M value. And when we go up, it's a multiplication. So I'm going from centimetres cubed to 1,000 centimetres cubed. So I'm going to multiply that answer by 1,000. And I'm now 1.318 big M. Now, you have to recognize at this point that this is our diluted vinegar, because that's really, really important. Because there's going to be a question in there about the original vinegar. So what we've done so far is worked out the concentration of our diluted vinegar. So always that we're going to have to do a conversion that gets us to grams per litre. And I'm going to show you 2 ways to do it. So using dimensional analysis, we now have moles. We want to find grams. Every time we know we have to find grams, we know that there has to be a molar mass calculation that we have to do. We're doing it for the ethanoic acid. So we need to fill in all of our bits. 12.01, it's going to be 1.008 by 3. It is going to be 12.01 again. It is going to be a 16. It is going to be a 16. And it is going to be a 1.008. I'm going to put that into my calculator. Okay, so it's an addition that we are doing. And when I do, I get 60.052. The 2 needs to decide what it's going to do to the 5. It's not going to do anything to it. So it's 60.05 is the number that I'm going to be using. So we have said 0.1318 moles. I want to end up with grams, and the conversion factors that we have are moles over molar mass, or we have molar mass over moles. So if I was to use it like this, that does not get rid of moles for me, so I have to flip my card for the dimensional analysis. So this is going to be multiplied by 60.05 all over moles. And I just exit and exit, and when I am done, it comes out as 7.916 grams in a litre. And again, this is diluted vinegar. Now, normally in our maths, they could ask us for any of these particular points. So they could ask for this, 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 and they could normally ask for this. But because now we have done the dilution, there's going to be a question somewhere where it's going to ask you for any one of those blue boxes for the original vinegar. And all you are doing is you're multiplying that particular answer by the dilution factor, which we worked out at the very, very beginning. So if I want to find out the concentration of the original vinegar as a big M value, all I'm going to do is take 1.1318 big M, and I'm going to multiply it by 10, and now I have the concentration of my original vinegar. If they asked for it in grams per litre, it would be the same thing. It would be 7.916 grams per litre. I would be multiplying it by my dilution factor of 10, and now I am 79.16 grams in a litre. We have one final little kick. So this is a units thing, and this is more like the real world. So if you look on the back of a can of beer, you will see percent volume per volume, and that's telling you how much alcohol is present in 100 centimetres cubed of your liquid. When we talk about vinegar, we're going to talk about percent weight per volume, and this means grams per 100 centimetres cubed. Now, if I had money for how every time somebody gets this wrong, I would be very, very rich. So if they had asked you for the percent weight per volume of your diluted vinegar, you would be taking our concentration, which was 7.916 grams in 1,000 centimeters cubed, and you now have to convert that to grams in 100. And the quick way is to just divide your answer by 10. Okay, so it would mean that I have 0.7916 grams per 100 centimeters cubed. All right, no, I didn't write that correctly. Okay, per centimeters cubed, but this is how you write your final answer, 7.916% weight per volume. If it was for the original vinegar, it would be 79.16 grams in a litre. Again, I'm going to divide it by 10, so it will be 7.916 grams in 100 centimeters cubed. And then to write my answer, it is 7.916% weight per volume. Okay, so we know that the vinegar titrations are going to have the kicks. The kicks are going to be the use of our dilution factor here. And finally, the converting into percent weight per volume. You've got this.